Hey there, it's the Math Doc back here again with another video on algebraic inequalities. This time we're looking at algebraic inequalities where the variable, or x, is preceded by a negative coefficient. So in this case we have negative 3x is less or equal to 9. And why are we specifically looking at this type of inequality? Well, it turns out that there's a trick that's involved with solving these. Why is that? Well, as always, we like to isolate our variable, x, right, in order to solve for the inequality. In order to do that, we would want to divide by negative 3, right? Well, it turns out that when you divide by a negative number, an inequality by a negative number, something has to change in the inequality, and specifically the direction of the inequality changes. So let's take a step back before we actually solve for this inequality and look at a simple demonstration. This is not quite even an example, but more of a demonstration of what happens when we multiply an inequality by a negative number. So let's look at this example. 3 is less than 5. Let's find these numbers on the number line. We have 3 and we have 5, and quite clearly 3 is less than 5. And this is very clear. Now, what happens if we want to multiply both sides of this inequality by the number negative 1? If we multiply the left-hand side, we get negative 3. And when we multiply the right-hand side, we get negative 5. Let's look at the number line again. So we have negative 3 here and negative 5. Now, what is the relationship between them? Well, negative 3 is actually larger than negative 5, right? And you can see that very clearly on the number line. So if negative 3 is larger than negative 5, let's put that in here. Let's write that out actually with different colors. So negative 3 is larger than negative 5. So what we see is we've multiplied 3 by minus 1 and gotten negative 3. 5 multiplied by negative 1 is negative 5. And then the sign of the inequality is switched here. From less than, we're going to larger than. And this is a very, very important rule. When we multiply an inequality by a negative number, and the same is true for division by a negative number, we have to switch the sign of the inequality. And this is the rule that we're going to practice now in this video. So let's look at the example that we were considering earlier. Negative 3x is less or equal to 9. Okay, so we would like to isolate x, right, our variable. So let's do what we would naturally do, which is to divide both sides of this inequality by negative 3. So on the left-hand side, we have negative 3x divide by negative 3. On the right-hand side, we have 9 divide by negative 3, and then recall we have to switch the direction of the inequality. So from less or equal to, we have to go to larger or equal to. Okay, now what do we get here? So we have negative 3 divide by negative 3 on the left-hand side. Negative divide by negative is a positive, and 3 divide by 3 is 1. So we just get x. Larger or equal to, and 9 divide by negative 3 is just negative 3 because we have a positive divide by a negative. So the result of this inequality is x is larger or equal to negative 3. We can show this on the number line. We have negative 3 and the entire rest of the number line to positive infinity. Another way to write this is just negative 3 to positive infinity, right? So this is the result, and we'd like to look at it from another angle to make sure that what we've done is correct. What do I mean by looking at it from another direction? Well, let's do something different. Instead of multiplying or dividing in order to isolate x, let's start by doing addition and subtraction. Let's add to both sides of this inequality 3x. Okay, we're just going to move the x from one side to the other. We're adding 3x, so we have minus 3x here, plus 3x is less or equal to 9 plus 3x. Now obviously the 3x here cancels with the negative 3x, and we have 0 is less or equal to 9 plus 3x. Okay, now let's subtract 9 from both sides of the inequality, and we have negative 9 is less or equal to 9 plus 3x minus 9. The 9's here cancel, and we have negative 9 is less or equal to 3x. Finally, now we can just divide by positive 3. And when we divide by a positive number, we don't have to change the direction of the inequality. So we have negative 9 divided by 3. That's just negative 3 because we have a negative divided by a positive is less or equal to 3x divided by 3, which is just x because the 3's cancel. So we have x is larger or equal to negative 3. And putting that on the number line, we have the same result, basically negative 3 to plus infinity. Right? And this is the exact same result we got in the previous analysis where we divided by negative 3. So we got the same result. Let's just test this result. Let's check it. So let's look at a number that's within this interval, say 0. So for x equals 0, we have negative 3x is just 0, and this indeed is less or equal to 9. What about number here, 5? For x equals 5, we have negative 3 times 5, which is negative 15, is indeed less or equal to 9. So that's correct. Okay, let's look at a number on the other side. Let's look at negative 5. So x equals negative 5. So we have negative 3 times negative 5. Okay, a negative times a negative leads us to a positive, so that's plus 15. Plus 15 is larger than 9. So it does not satisfy this inequality. So it looks like we did get the correct result. Let's look at one more example here. This example is just slightly more complicated, but not by much. In order to isolate our variable x, we will have to first subtract 5 from both sides of this inequality, right? So let's subtract 5 from both sides. We have 5 minus 2x minus 5 is less than negative 3 minus 5. Okay, the two 5's here cancel, and we have negative 2x is less than. Negative 3 minus 5 is just negative 8, right? We've made it even more negative. Now, let's divide both sides of this inequality by negative 2. So remember the rule. On the left-hand side, we have negative 2x divided by negative 2. On the right-hand side, we have negative 8 divided by negative 2. And now, we have to switch the direction of the inequality. So instead of having less than, we're going to have larger than. Okay? So now just to solve this, we have negative 2 divided by negative 2 on the left. That leaves us with just x because the two negatives cancel, as do the two 2's. On the right, we have negative 8 divided by negative 2. So we just have positive 4. And together, this result is x is larger than positive 4. So finding this on the number line, we have just 4 and any x that is larger than it. And I made a little mistake here because really we should only have an empty circle here because we're not including 4. We have x larger than, not x larger or equal to. And in other ways we can write this is between 4 and positive infinity, that interval not including the edge. Let's test this result. Let's do a check. Okay, so let's check first of all for x equals 4. So right on the boundary. Well, 5 minus 2 times 4 equals to 5 minus 8, which is equal to negative 3. Negative 3 is not less than negative 3. It's actually equal to negative 3. So indeed, at 4, we are not satisfying this inequality. Let's look at 5 at a larger number, x equals 5. We have now 5 minus 2 times 5 is just equal to 5 minus 10, which is equal to minus 5, which is less than negative 3. So for 5, we do satisfy this inequality. Let's look at a couple of numbers on the other side here. Let's say x equals 2. We have 5 minus 2 times 2 equals 5 minus 4, which is 1. 1 is larger than negative 3. So for x equals 2, we do not satisfy this inequality. Right? And going even further to the negative numbers, let's look at x equals negative 2. We have 5 minus 2 times negative 2. That is 5 minus 2 times negative 2, which is negative 4. 2 negatives, so we have 5 plus 4, which is equal to 9, which is larger than negative 3. So again, negative 2 does not satisfy this inequality. So it looks like we solved this correctly. For any x larger than 4, this inequality is satisfied. Finally, let's look at just one more example. This one is just slightly more complicated, and it's really only complicated because instead of dividing, we're going to have to multiply by a negative because we have a quarter, we have a fraction here. The other complication is that we have parentheses, and that's we're going to have to be reminded about order of operations, that we never solve by opening the parentheses before we've taken a look at what's happening outside the parentheses. So let's get started. The first thing we're going to want to do is obviously multiply by negative 4, right? So we multiply both sides of this inequality by negative 4. On the left-hand side, we have negative quarter times parentheses x plus 2 times negative 4, right? And on the right-hand side, we have 2 times negative 4. What happens to the inequality sign? Well, we have to flip it. So going from less or equal to 2, we go to larger or equal. Okay? Let's perform the multiplication. Well, we have 2 negatives here, right? Here and here. And so they cancel, and we have plus 4 divided by 4 times x plus 2 is larger or equal to 2 times negative 4 is just negative 8. The 2 4's here cancel, right? 4 divided by 4 is just 1. And we can open our parentheses. Now we have x plus 2 is larger or equal to negative 8. Now we'll subtract 2 from both sides, and we have x plus 2 minus 2 is larger or equal to negative 8 minus 2. The 2 2's here cancel, so we have x is larger or equal to negative 8 minus 2. We're making it even more negative, so it's negative 10. So x is larger or equal to negative 10. Well, I think we're going to have to draw another number line so that we can fit this result here. Let's write it like that. Okay, and so we have x, let's change our color. X is larger or equal to negative 10. Let's check our result just to be sure we did everything correctly. Let's look at an x that is larger than negative 10. Let's say look at negative 5 here. So minus quarter of negative 5 plus 2 equals the negative quarter of minus 5 plus 2 is just negative 3. That is equal to plus 3/4, right? Plus 3/4 is less than 2. And so at negative 2, at negative 5, sorry, we are okay. Let's also look at a number on the other side. Let's look at negative 15, okay? So we have negative quarter times negative 15 plus 2. That just equals negative 4 times negative 15 plus 2 is just negative 13 equals 13/4, right? Now 13/4, let's reduce this. We have 12/4 is just 3, right? So we have 3 1/4. 3 1/4 is actually larger than 2, right? So 3 1/4 is larger than 2. So at negative 15, we do not satisfy this inequality. Okay, so the two numbers we've checked show that our result is correct. Okay, so the goal of this video was to look at inequalities where we may want to multiply or divide the inequality by a negative number, and to explain why when we do this we have to change the direction of the inequality, and to show a few examples. So hopefully this video was clear and it explained to you why this is correct to do. And if you have any questions about this type of inequality, or you'd like me to look at a specific example, please comment below, and I will take a look at all your questions and try to respond and add videos if this specific rule needs more explanations. As usual, thank you for joining me for another video, and please subscribe, like, and of course comment if you have any questions. See you here again on our next video.